applications of linear functions. So my first example, you're pumping water into a swimming pool at a rate of 5 gallons per minute. When you started, there was 200 gallons of water in the pool. And I want to find a linear function, v, that models the volume of water in the pool at time t. Well, here I'm given two pieces of information: the rate and how much we started with. So we know we want our function to be called v, and we're modeling it with time t, so v of t. And this rate here, 5 gallons per minute, this is just another word for slope. So I can write this as 5t. And then the 200 gallons is like my starting point, or my y-intercept, so plus 200. So every time I'm given a rate, that just means slope, and a starting value is my y-intercept. So I was able to get this equation here. The second part of this question, if we know the pool holds 600 gallons, how long does it take to fill it? Well, we've already discussed our model. We had a rate of 5, so that was my slope, and a starting point of 200. And now I know how much it holds, so I know what the volume should be. So we have that volume is 600, and we need to find t, or time. We can subtract 200 from both sides to get 400 equal to 5t. Dividing by 5 gives me 80, and so it would take me 80 minutes to fill this pool. This is the first type of application we have for linear models, where we know the rate and the starting value, and so we can easily get the equation. Let's look at the other type. After 1 hour, there are 2 inches of rain in the rain gauge. After 5 hours, there are 7 inches of rain in the gauge. We want to find a linear function r that models the amount of rain in the gauge at time t. So this one's trickier because we don't have the set rate or the starting value. However, we do have helpful information. So we know that after 1 hour, there are 2 inches of rain. So essentially that tells me that this function passes through the point 1, 2. I also know that after 5 hours, there's 7 inches of rain. So it also passes through the point 5, 7. And from here, we know how to find a line passing through 2 points. We need to start with the slope. So that's y2 minus y1 over x2 minus x1, or 5/4. We then use our point slope form, y minus y1 equal to mx minus x1. I'm going to use this first point here, so I have y minus 2 equal to my slope, which we just found, times x minus x1, which is 1. Y minus 2 equal to 5/4 x minus 5/4. Then we can add 2 to both sides. 2 minus 5 over 4 is 3 over 4. So I have 5 over 4x plus 3 over 4. So my actual function is just changing y to this new function notation, 5/4 x plus 3 over 4.